Hello everyone, welcome to Psych Laboratory. And now I will explain you about superposition of harmonic vibration. And these several points I will explain to you. Objective, basic theory, tools, procedure, and data processing. For the procedure and data processing, you can watch the demo or video. First is objective. The objective in this model is 1. Measure the frequency and amplitude of the combined quantity of harmonic the oscilloscope display. 2. Understand the superposition of harmonic vibration in line from the oscilloscope. 3. Understand the superposition of harmonic vibration perpendicular from the oscilloscope. Okay, the second is basic theory. Calibration is a way to determine the truth value shown on the avalanche inception, measuring tools, and testing tools. Calibration also a way to standardization tools. Calibration is used to determine the accuracy of measuring tools. So example, you have measuring tool and then we have to check is the tool according to standard. If not yet, we have to calibrate the tool to obtain the result which we deserve. Okay, next, superposition of harmonic vibration. What is superposition? Superposition is the sum two or more. Vibration is the move back and forth around balance point and have same amplitude. So, superposition of harmonic vibration is the sum of two or more harmonic vibration which can cross the same space without any connection between waves. Maybe you little confused. What the difference between vibration and wave? Vibration is the move back and forth around balance point and have same amplitude. That the wave is vibration that propagates. And then what is frequency and amplitude? Frequency is how much vibration per second, and amplitude is the farthest deviation from the balance point in vibration. Okay, next, superposition of harmonic vibration can be divided into inline and perpendicular. In superposition of harmonic vibration inline, it have pelayangan wave and complex wave. Pelayangan wave created by superposition two waves which have little frequency difference, while complex waves have a big frequency difference. Next, superposition of harmonic vibration perpendicular. It have a result. If superposition of harmonic vibration we plot in perpendicular, we will get the result. What is result? Result is a result in display oscilloscope which have compression phase difference, frequency, and amplitude from the wave. Next tool, we have oscilloscope, generator audio, and cable probe. In generator audio, we have button power on off, to hold the black one and red one, to connect the generator audio to oscilloscope with cable probe. This button is setting amplitude, and this button to setting frequency. And oscilloscope, we have the channel 1 this side, and we have channel 2. In channel 1 we can setting the vertical, position the wave. In channel 2 it's same, and we can show the channel 1 or channel 2 or dual or add. And the horizontal, for from further you can go to the procedure and watch the demo or the video. Today we will practice about superposition of harmonic vibration. Any tool we use in superposition of harmonic vibration is oscilloscope. The function of oscilloscope to show the wave from audio source. And the next is oscillator or generator audio. The function of oscillator is to produce some vibration with frequency and amplitude. And the last but not least is cable probe. The function of cable probe is connect the oscilloscope and oscillator. Now I will explain you about oscilloscope. In this corner, to calibrate the oscilloscope, and then this button to setting the brightness of oscilloscope. This side to setting the amplitude, this side to setting the frequency. This button to up and down the wave, and this button is same. And then this hole to connect to channel 1, and this hole to connect in channel 2. In frequency, we have button to multiple the frequency. The multiple is 0.5 millisecond, while in amplitude is 0.5 volt. This is X and Y button we can use in superposition of harmonic vibration perpendicular. Now I will explain you about oscillator. In oscillator, decide to setting amplitude and decide to setting frequency. In oscillator, for amplitude, we have multiple in this button and in there. How to multiple the amplitude? Example, we choose 5 and we choose 10. 5 multiple 10 multiple 20 mVpp. We have to conversion mVpp to VPP. So 5 multiple 10 multiple 20 divided by 1000. The result is 1 VPP. And for the frequency, we have the multiple 2. This for frequency and this for multiple frequency. Multiple 1, multiple 10, multiple 100, multiple 1000, and multiple 10,000. And this button to setting the wave. and we use a line wave and sinusoidal wave. Calibrate. Before we start practice, we have to calibrate. How to calibrate? We have to adjust the oscilloscope. In oscilloscope, written to VPP and 1 kHz. How to know that from up to down is amplitude and from left to right is frequency. And we have to count the square in display. For amplitude 1, 2, 3, 4. 4 square multiple 0.5 volt. So 4 square multiple 0.5 volt is 2 VPP or 2 volt peaks to peaks or 1 wave. Next, we calibrate the frequency. We setting a little bit and you can count the square from the end of the line to the end of the next line. Okay, we count 1, 2, 2 square. We multiple 2 square with multiple frequency and multiple frequency still in periodic. We have convert to frequency. 2 square multiple 0.5 millisecond. The result is 1 millisecond. It's still in periodic. We have to convert to frequency. The result is 1000 Hz or 1 kilohertz. With that, the calibrate is done because in display and written in corner it's same. Experiment 1. We will get data from experiment 1. We setting amplitude and frequency in oscillator. First, we count the amplitude. 5 multiple 10 multiple 20 mVPP. The result is 1000 mVPP. We have to convert mVPP to VPP. The result is 1 VPP. Now we count the frequency. 5 multiple 100 500 Hz. Now we appeal data in oscillator and oscilloscope. It's same or not? We count the amplitude from up to down. 1, 2, 2 square. 2 square multiple 0.5 volt. The result is 1 VPP. And now we count the frequency. From the end of the line to end of the next line. 1, 2, 3, 3 square. And 1, 2, 3, 3 dot. 3 square and 3 dot. Value of 1 dot is 0.2. So the result is 3.6. 3.6 multiple 0.5 millisecond. So the result is 1.8 millisecond. In periodic, we have to convert to frequency. Millisecond to second is divided by 1000. So 1.8 divided 1000 and we convert to frequency. So 1000 divided 1.8. The result is 555.56 Hz. Experiment 2. Data experiment 2. You can count the frequency and amplitude like experiment 1. You guys have to count that. For data experiment 2, we setting amplitude button 6 and we setting frequency button just 6. And you guys have to count that the amplitude and frequency in oscillator. Now we see the oscilloscope. It's same or not? Now the oscilloscope. We count the amplitude and frequency. For the amplitude, we see how many square from up to down. For the frequency, you can see how many square and dot from the end of the line to the end of the next line. Experiment 3. For data experiment 3, we setting amplitude button choose 7 and frequency button choose 7. You guys have to count the amplitude and frequency in oscillator. Now is oscilloscope. We count the amplitude, how many square from up to down. For frequency, you can see how many square and dot from the end of the line to the end of the next line. Experiment 4. For data experiment 4, we setting amplitude button choose 8 and frequency button choose 8. And you guys have to count the amplitude and frequency in oscillator. Now the oscilloscope. You can count the amplitude to see how many square from up to down and frequency square and dot from the end of the line to the end of the next line. Superposition of harmonic vibration in line. In superposition of harmonic vibration in line, you have pelayangan wave. We will show you 3 pelayangan wave. The first is same amplitude, same frequency. Second is same amplitude, different frequency. Third is different amplitude and different frequency. First, we setting amplitude oscillator channel 1 is 1 VPP, same amplitude. For the frequency, oscillator channel 1 and channel 2 is 600 Hz. We can see the display of channel 1 like this and channel 2 like this. You guys have to draw this. And for pelayangan wave like this. You guys can see the first pelayangan wave, same amplitude and same frequency. Now second pelayangan wave, same amplitude, different frequency. For amplitude still same 1 VPP, but the frequency is different. We setting oscillator channel 2 is 800 Hz, channel 1 600 Hz. You can see in the display gelombang pelayangan like this. For the channel 1 like this. For the channel 2 is like this. More closely. Okay, next to the third pelayangan wave. Different amplitude and different frequency. In oscillator channel 1, the amplitude is 1 VPP, and oscillator channel 2, the amplitude is 1.4 VPP. And for frequency, oscillator channel 1 is 600 Hz, oscillator channel 2 800 Hz. Setting channel 1 to display the wave like this, and channel 2, the wave in channel 2 is like this, and pelayangan wave like this. There it is for pelayangan wave. Then next we will see complex wave. For complex wave we have two data, 6 kHz and 60 kHz. We setting amplitude and frequency in oscillator channel 1 and oscillator channel 2 it's same. For amplitude 1 VPP and for frequency 600 Hz. We change the multiple frequency oscillator channel 2 to 1000, and the result is 6000 Hz, and this display complex waves in frequency 6000 Hz. And next we change multiple frequency in oscillator channel 2 to 10,000. The result is 60,000 Hz. This is complex wave in 60,000 Hz. Superposition of harmonic vibration perpendicular. Now I will explain you about superposition of harmonic vibration perpendicular. You guys have to draw a lysogyte with manual method and a lysogyte with oscilloscope. I will show you for lysogytes in oscilloscope. Lysogytes 1 appeal 1, 1 appeal 2, 1 appeal 3, 2 appeal 3. Now 1 appeal 1. We setting the frequency in oscillator channel 1 is 600 Hz and oscillator channel 2 is 600 Hz. To show superposition of harmonic vibration perpendicular in oscilloscope, we press X and Y button. This for superposition of harmonic vibration 1 appeal 1. Next 1 appeal 2, which means we have to setting oscillator channel 1 300 and oscillator channel 2 600. For a wave 1 appeal 2, you can draw like this, like in display. And next 1 appeal 3, which means we have to setting oscillator channel 1 200, oscillator channel 2 600. For wave 1 appeal 3, you can draw like this, like in display. And next, to appeal 3, which means oscillator channel 1 we setting 200 and oscillator channel 2 we setting 300. You can see the wave to appeal 3 like this. Next, we will drawing Lisa jaws with manual method. Before we draw Lisa jaws, we have to make x-axis and y-axis. And then we make two circles in quadrant 2 and quadrant 4. I will give you example drawing Lisa jaws 1 appeal 2. For 1 appeal 2, we make line like this. In quadrant 2 is vertical line and horizontal line. In quadrant 4 is vertical, horizontal, and diagonal. And we have to give the number in the line. In quadrant 2 is counterclockwise. In quadrant 4 is clockwise. We give the number start with 0. 0, 1, 2, 3, 4, 5, 6, 7, and 8. And now we will give number in quadrant 4 clockwise. Start with 0, 1, 2, 3, 4, 5, 6, 7, 8. When you done give the number, connect between 0 and 0, 1 and 1, 2 and 2, and so on. Like this. 0 with 0, give the dot. 1 with 1, give the dot. 2 with 2, 3 with 3, 4 with 4, 5 with 5, like this. 6 with 6, same dot. 7 with 7, and the last is 8 with 8. And then we have to connect the dot. Start from 0 to number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8. And you guys have to draw Lisa Jones in the journal 1 till 3. So there it is. Practice superposition of harmonic vibration. Thank you and bye.